Welcome to our paper titled Lip-to-Speech Synthesis for Arbitrary Speakers in the Wild. Please use headphones for a better user experience. Our work revolves around generating speech solely from lip movements. This problem was first approached in 2017 using speaker-specific models trained on datasets collected in laboratory settings. Such datasets contain less head movements and emotion as well as a very small vocabulary, leading to a much easier task. The next major leap came in 2020 with Lip2Wave, a speaker-specific model for modeling speakers in unconstrained environments. This model was able to successfully handle in the wild conditions. It also needs hefty amounts of data per speaker to work, making it very hard to scale to practical use cases. In this work, we aim to train a network that can successfully handle any speaker and produce speech in any voice, without any speaker-specific training. The simplest solution for this problem is to convert lip movements to text through lip reading, then use a TTS to generate the speech output. Lip-to-text systems are known to work for any identity in the wild, and multi-speaker text-to-speech systems are gaining prominence. However, will such an approach work for converting lip movements to speech? Let us see an example.
That's not an ancient Roman mask.
That's not an ancient Roman martyr.
So I'll ask you again.
What I do again.
Since lip-to-text synthesis is comparatively an easier task, the content, that is, the words generated by the model, are accurate. However, the model fails to match the input video. The speech generated is out of sync with the lip movements. Thus, we do not use this approach, instead designed an end-to-end model for this task. Let us first check some of the results from our model.
Power sides in the sides.
She wants to.
You don't deserve my grace.
You tell that you are my grace.
As we can see, our multi-speaker model can produce legible outputs for words, phrases, and even sentences. Now let us check our task in more detail. Multi-speaker lip-to-speech is an inherently ill-posed problem. Lip movements are an ambiguous source of information due to the presence of homophones. Because of this, previous works limit themselves to individual speakers speaking a limited vocabulary. They use large amounts of data per speaker. But, we aim to train a single model that works for any speaker without any vocabulary constraints. Multi-speaker lip-to-speech task also has far more stochastically varying factors such as voice, prosody, accents, and homophones spanning a vast vocabulary. We show that the single-speaker models do not scale to the multi-speaker case. A key reason is that these models enforce a one-to-one mapping between the input lip sequences and the speech, which is very detrimental in the highly stochastic multi-speaker scenario. Instead, we learn to map the distribution of lip movements to a distribution of speech sequences. We achieve this using a VAE-GAN approach that creates a shared space where these multimodal distributions are aligned. We can decode from this distribution and generate intelligible speech outputs for the first time. Since we map inputs and outputs to distributions instead of single points, we explicitly model the stochasticity of the task, which previous models ignore. Let us now check some comparisons with previous works that were originally proposed for single-speaker lip-to-speech synthesis. We modified the models to include a speaker embedding and trained them for the multi-speaker lip-to-speech. All the samples presented here are generated directly by the model.
These are my words.
These are my words.
These are my words.
On the negative side,
On the negative side.
You realise what this means?
It's a precise what this means.
Soothing like novels becoming.
You realize what this means.
Our multi-speaker model also impacts the single-speaker lip-to-speech task. Specifically, our pre-trained multi-speaker model can adapt to single speakers in a data-efficient manner. In the graph, we see that our multi-speaker model uses 4x less data to achieve comparable results to the state-of-the-art single-speaker model.
Is it A, the 680 nanometer absorbance, B, the 550 nanometer absorbance, or C, the 470? It's in and it is 680 nanometer. So it means B, the 550 nanometer absorbance, or C, the 470 nanometer. Is it A, the 680 nanometer absorbance, B, the 550 nanometer absorbance, or C, the 470 nanometer absorbance?
We present some more results from our multi-speaker model. All results are generated from the same model without fine-tuning further on any specific speaker.
Waiting for
was probably
outside
Prison.
Fast and furious.
But while many about having purchased,
very few remain.
And before that,
an opportunity to pay tribute to all members.
that's what you said.
So obvious.
very expensive.
It is highly evident that our model produces intelligible speech outputs for different identities and voices solely from lip movements. Our approach depends on the quality of alignment between the speech content distribution and the lip distribution. As described in the paper, we use a combination of local and global KL divergence loss to enforce this strong alignment. The improvement due to using a combination over using only a global KL loss can be seen in the following example.
There's a fair chance you will be.
In our next and final example, we show that our model is robust to silences, and that it can generate silent segments if the lips are not speaking anything. As we can see, our model produces silent segments of speech in the absence of lip movements. In summary, we are the first to show that it is possible to generate intelligible speech for arbitrary speakers in the wild from only lip movements. Our method uses a minimal amount of data per speaker with no explicit constraints on vocabulary. Simultaneously, our work also makes existing single-speaker models 4x more data efficient without any degradation in their performance, thus, making them far more scalable. We will release all our codes and models publicly to support future research in this task. Thank you for your kind attention.